Welcome back. Now we will look at a simple schematic to study open systems. So what I am going to do is now draw a very simple open system here. You will notice that I have drawn this open system here. This is the shaded part that I am going to draw, and it has one inlet and one exit. The location of this inlet and exit is not of any consequence, neither is the shape of this open system. For example, I could have as well drawn it in a reasonably amoebic fashion here and drawn the inlet and exit somewhere else. For example, I could have drawn an inlet here and an exit here. So all I am doing right now is considering an open system with one inlet and one exit. So for this open system, the properties can actually change with time, and not only that, one need not find a unique property throughout the open system. If one can find properties for the entire system, we will try to label them, but mostly these properties would be a function of time. So for example, one could have the mass as a function of time, one could have the energy as a function of time, one could have the entropy as a function of time. As a result, one would write m as a function of time, E as a function of time, H as a function of time, and so on. So apart from this, what one assumes is that one can have very defined properties at the inlet and exit. This means that we assume some kind of a local equilibrium at the inlet and exit, and that we know very well what the properties of the fluid are at the inlet and at the exit. Thus at the inlet we can definitely specify at any instant of time what is the inlet energy, what is the inlet velocity, what is the inlet pressure, what is the inlet temperature, and so on. And hence what one would like to do is make a list of these properties at the inlet and exit and label them with a subscript. So typically I would label the properties at the inlet with a subscript I and the properties at the exit with a subscript E, and what I will do is I will just list them out right now. So I would write it here: area, density, internal energy, velocity at the inlet and at the exit, AI, AE, rho I, rho E, UI, UE, VI, VE, and so on. So we make a list of the properties at the inlet and exit. I should again mention at this time that we are making another assumption here, that we will assume that these properties are uniform across the inlet and similarly uniform across the exit. That is, we are assuming a one dimensional situation at both the inlet and exit. Of course, one could have a profile at the inlet and exit, in which case we would just have to integrate at the inlet and integrate at the exit. For example, we can actually have uniform flow at the inlet, but the flow may not be normal to the inlet, in which case for the mass entering the system we need to consider only the normal component of the velocity. But if we want something like the kinetic energy of the incoming mass, then we would have to take the entire velocity and square it and multiply it with the mass and so on. So in general, this is the whole schematic for the system. We have a system with one inlet, one exit. We know very well defined properties at the inlet and exit. We have assumed one dimensional situations at the inlet and exit, and we will try to define properties for the system. All of these are functions of time. Apart from this, as any other system, the system will also be interacting with the surroundings, and hence there would be a heat interaction Q and there would be a work interaction W. Both of these would be functions of time, and hence for the open system we would have a Q and a W term, and the sign convention would be the same as before, that is Q, heat entering the system, would be considered positive. Similarly, work done by the system would be considered positive. So, this is in general the simple system we will consider. The next step that we have to do is consider what happens with the mass flowing at the inlet and mass flowing at the exit, and one will realize that we will be discussing this very often, what is happening at the inlet and exit, and hence we will cover it in the next snippet. Thank you.